Well, hey everyone, and welcome back to another tutorial video in the Dungeon Generation tutorial series. In the last episode, we went ahead and were able to draw all the lines, the paths, excuse me, from one room to the next. We were able to get it done, and I figured out what it was causing this error, and I'm going to show you what it is in a minute and how to fix it. But for now, I'll show you how everything just draws out. So it says in here we drew 10 rooms. And if you look, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the number 10 is down here, and there's lines drawn to every single room. Now, in regards to this error, whenever you're looping through a list, you gotta remember, you don't go through the count itself. You go index, -1. Now, when we go ahead and do this, and we hit play, and we'll do 30 rooms. Because 30 is nice. 30. Same thing. Yep, it's the same thing. What did I do now? Did I not save it? Okay. -1. Save. Draw path. Save. Room count. -1. Now we'll go back. Clear it. Save the scene. Now we'll draw it. And there we go. Now we drew it and then there's no errors. It helps when you save. And it generated 21 rooms. And there they are. 21 rooms. Generated them for you. So what I'm going to do now is we're going to go ahead and create a script real quick for our camera. And we're going to move our camera around. And we're going to call this camera controller. So go ahead and create camera controller. Alright. And we can open that one up when it's done. That it will be a mono behavior, obviously. We'll come into here and we're gonna need some variables. So what I'll do is we're also gonna have a zoom in, zoom out function. But first, let's work on the movement. So let's go ahead and set a public private int camera speed, and we'll make it a serializable field. So it can be changed in the inspector, and by default, we'll set it to 10. That'll move 10. Then we'll come into here. That'll be by default. And then we'll have an update function. We're going to do input, get key down. So if in the frame we press the key down, key code A, then I want this camera's transform dot position to move camera speed times time dot delta time in this direction, vector 3 dot left, which is -1 in the x direction. That's what we want there. And then we'll copy this. Oh, sorry. Okay. Come here, copy, 3 more times, 1, 2, 3, and we're gonna want to move left, we want to move right will be the D key, and there's a vector right, and then we want to move up, so we can do this, vector up, which will be in the up, 1 in the Y, and then we want to move down. We'll make down, guessed it, down. So whenever we press these keys, the camera's going to move in a direction as fast as we told it to over delta time. So we'll come into here, back, let it compile, go to the camera, drag over the camera controller, hold on, you drag. There we go. Okay, so we'll do this. And we'll go ahead and hit play. Gonna generate. And then now when we move the keys. Oh, that's my fault. We don't want key down. We want get key. We don't want it just the instance it's framed down. We want to just press it and hold it down. That'll work for movement. If you just want to tap it and have it move like that, you can, but this is a better way to do it. Key down. Get key. So every frame this key is pressed is going to constantly move. That's what we want. We don't want it to just move little by little. We want it to move over time, like this, as we hold it down. So we'll go ahead, hit play. We'll move the mouse. Press the D key. Everything moves to the right. We can follow this path. If we push the up key, we start moving up. If we push W and D, we can move at an angle. Same thing with W and A. A goes left, D goes down. But look at this map, though. This is insane. But what would be really cool is if we could zoom in and out as well. So what we're going to do for that is we need to change the perspective on this camera to orthographic. And that's pretty much it. You can just leave it as that. And then now we can come into here and we will make sure that inside the update function, what we can do is on start, come into here and update. Say the camera dot main dot orthographic size minus equal camera dot main dot orthographic size times input dot get axis. And the axis we want to get is mouse scroll wheel. So whenever you input from the mouse scroll wheel, it's going to give it a number. You're going to take that number, multiply it times the orthographic size, and you're going to subtract it from there. It takes a portion of it. Okay? And then now we're going to do camera.main. Well, you know what? Before I show you that, let me show you what happens when we do it like this. So keep an eye on this 5 right here. It's gonna change. Hit play. We move around, do whatever we gotta do. That's cool. But like when you scroll the mouse wheel out, this happens. Well, look. We can't even do that anymore. It's not a camera view. Or we can scroll way too far in. We don't want that either. So we need to set a place to clamp it. So we need to give it some variables to say, okay, we don't want it to be going too far here and too far there. So what we can do is we can come into here and say private int And then we'll do min size, or like the min zoom, and we'll put it as 5. And then we can do private int max size. And we'll set that to 10 for now. And we'll serialize these fields so we can actually change them inside the inspector if we want. This will come into here. We'll do camera.main orthographic size equals mathf.clamp. We're going to clamp this number, and the value is going to be camera dot main dot orthographic size. We're clamping this value with the min size of what we told it to and with the max size of what we told it to. So that means no matter what, the number will never be smaller than this and never be bigger than this, and this is the number we're clamping. And I'm going to show you how to make this much more efficient in a moment. We'll verify that this works. Alright, got our keys. Let's find some rooms. Here's a room. Zoom in, we can't. Zoom out, we can't go further than this. This is the room. And this is what the dungeon looks like. And this is as close as you... I mean, you could change these. If that's the closest you want to get. It's like 5. You can do this. You know, that's really neat. And another thing... But I mean, this is it. Like, this is the entire tutorial as far as what I wanted to show you in regards to making a dungeon. And we got our zoom in and our zoom out. We got the camera moving. We know what it looks like. You can also come in here to the scene if you want to look at it all together. You know, move it around and see what it all looks like. But, I mean, that's pretty much it. I'll show you one more thing just for good practice. Inside of here, you don't want to do this. I'm calling camera.main.orthographic size every frame multiple times. I'm caching it here, 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 and here. That's ridiculous. We don't need to do that. We can literally come into here inside the start function. And then we can just set a private variable. Set a private camera, like this, and then we can just do camera set to camera.main, like this. So basically what's going to happen is it's going to say, hey, when the scene loads and this script runs, like this script loads, I want you to find the camera in the scene that's tagged with camera.main, because inside of here, if you look at the camera, it's tagged right here, main camera. So it's going to go in the scene, find the object, the camera tagged with camera.main, cache it. So it's not going to keep doing this every single frame. It's only going to do it the one time. And then now all you got to do is go in the camera and access its orthographic size. That's it. So you're not doing that every single frame. There you go. So now the only thing we're accessing every frame is its orthographic float size. That's it. And now to prove, I mean, it'll still work. You're not going to notice anything different, but that's just one of those things, like over time, that can really complicate things. It can really slow your programming down. If this gets up to being tons and tons and tons of tiles, that can really slow everything down. And then here's you zoom in, you zoom out, and it moves around. That's it. Now you can get your little player however you want to do. Put him in here walking. You know what tiles he can walk on. We set up the tiles to where the tiles are actually walkable or not. You know, so you can tell the player which path he can take to walk, which one he can't. You can do some really cool things. Sorry about the way the math, the logic looks in here, but I mean, this is it. This works. Now, if you take all of this out right here and you go into grid behavior, into create room, and you take this out, you can take this out. I mean, you can. If you want your rooms to intersect and be inside one another, you can do that. You totally can do that. It's just up to you. I preferred them not to intersect, so I made this, but pretty much it there. I do thank y'all for sticking with me through this series. I had a lot of fun with this one, as with all of them, but this one was just... I really did like this one a lot. So I'm glad y'all stuck with me and went through the journey with me. If you want to see any more tutorials in the future, let me know what you would like to see. Real quick, before I let you go, one cool thing you could do inside of here, you see how when we're creating the room, we got these are not walkable. See right here how we say we're right now inside of a room object. Remember how I was telling you when you go into Unity and you click play, you come into here, you come into the console, okay, you click this. So if I double click this tile, you see how it brings it to this black tile here? Remember, this is actually part of the room. We've established that. Okay? Well, the reason it stays a black tile is because when we're setting up the rooms here, we're not saying if it's not walkable, set it to something else. You could do that. You could come right here and say, while it's walkable, set it to a floor. You can create another sprite up here, okay, and it could be called, like, you could change this wall to be, like, empty tiles, and then you could change another one and actually call it wall. And you can come into here and say, hey, if the tile is walkable in this room, I want it to be a floor. Else, if it's not walkable, I want you to set that tile to a wall tile. And your wall tile can be something different. So that way, whenever you load up a room inside of here, you're going to see your walkable tiles. And then around the floor, you're actually going to see different textures for the different sprites for the walls. And then that way, the only thing black in your screen on those tiles everywhere else are just there just to be there. Those are just tiles that are not being used at all. And then that way you have 3 different sprites. You have one for your tiles not being used, which are part of the general dungeon. You have the one tiles that are just walls around the room. And then you have the floor tiles within a room. So that's one of the cool things you can do with it too. I just want to throw that out there in case any of you wanted to go about it and try to do something a little extra. That'll point you in the right direction for that. But I hope you enjoyed the series. I did. I had a lot of fun with it, and I hope to be doing some more soon. And hope you're able to stick around and enjoy more. Thank you, and y'all have a blessed day, and I appreciate it. Bye.